Good morning, good afternoon, and good evening, everyone. I'm Matt Geisey, VP of Marketing at Liquibase, and I'd like to thank you for joining our webinar, How to Architect Modern Database CI/CD Pipelines on AWS. First, let's cover a few housekeeping items. Today's webinar will be recorded. We welcome questions throughout the webinar, and we ask that you post them in the Q&A panel instead of the chat. Panelists will answer your questions at the end of the presentation. The recording will be shared following the webinar via email. I'm honored to introduce our host for today, starting with Harpreet Burke. Harpreet has over 20 years of experience working with databases, including almost 15 years at Gartner managing the database engineering group. He was an AWS customer for 5 years before joining AWS's modernization and migrations group as a solution architect. Michael Levos is a senior solution architect at Liquibase. With his deep experience in cloud environments, systems, and DevSecOps, Mike has helped many companies successfully implement database release automation using their CI/CD technologies. Finally, we have Pete. Pete Pickerel is our co-founder and director of product at Liquibase. Pete works directly with our vast community of customers, partners, and open source users to understand their needs and drive our product strategy and direction to deliver the promise of DevOps for the database. Mike, I'll hand it over to you.
Thanks, Matt, and welcome everyone. Today we're going to talk about a few things. So first we're going to talk about the top considerations as you bring your databases into your continuous integration, continuous delivery pipelines. We'll talk about a reference architecture that actually uses AWS resources and Liquibase. We'll move into a live demonstration of a database CI/CD in action, your continuous integration, continuous delivery actually running within AWS resources. And then we'll land on how do you get started with your own database DevOps implementation using AWS. So thank you all for submitting and joining this webinar today. We took a poll as you were entering or registering for this, and these are some of the results, the live results that we have as part of the platforms that you're actually using in terms of cloud resources. So there's quite a few of you that are using AWS resources, a few using Microsoft on-premises, still Google Cloud Platform, and there's a few using other kind of resources. In terms of data stores, so there's quite a few teams that are still using relational type databases, Postgres, RDS, MySQL, Oracle, etc. There's a few using more unstructured, purpose-built databases like a Mongo or a DynamoDB, and then a few of the folks are using graph-type databases. So thanks for the feedback. Thanks for the information in terms of helping us understand where folks are landing, what they're still using. So in addition to that, we'd like to take a little poll in terms of understanding that the folks that have joined here. So we'll go ahead and do that poll here. Matt, if you want to go ahead and show our poll to folks here. And so what we're asking here is, are you using AWS as a database? Are you using AWS for your CI/CD tooling? Are you using both, or are you using things elsewhere? So if you could answer that poll, that would be great. And we'll provide that feedback here in a minute. So Matt, if you want to let me know how many folks, I can't actually see how many folks have actually registered.
We've got about 70% so far.
Okay, we'll give it just a few more seconds here for folks to actually respond. So again, if you're using AWS for CI/CD tooling, if you're using AWS for your database, if you're using AWS for both, or there's some folks that are using neither. So that will definitely help us understand the audience here. How are we doing in terms of registration now?
I think it's slowed down enough. I think we'll just go ahead and end the poll.
Okay, great. So we'll end the poll and we'll actually share those results. So hopefully you should see there's quite a few using about 40% or so are using database technologies from AWS. There's about around 15% using CI/CD tooling. Quite a few of the team is using both, and some are using neither. So thanks for that information. So in terms of the top 5 considerations, as you built out your continuous integration, continuous delivery pipelines, we'll talk about these in detail. So a couple of things to look at is the process needs to be scalable. As you kind of increase the number of databases, as you increase the resources that you're using, we need to be able to scale out. The database changes need to be treated like application code. So just like you're doing today with your CI/CD process for your application side, the database needs to marry and move in with the application side of things. Along with going faster, you also want to make sure you're still testing and your compliance needs are actually part of that pipeline. So we'll talk a little bit more about that. Making sure as part of the design, we're talking about DevSecOps. So you're designing the systems, those CI/CD pipelines with security in mind. And then lastly, in terms of monitoring and understanding where things are, creating the right level of visibility to the right folks at the right time. So Harpreet, I'll pass it over to you in terms of kind of talking a little bit about this first one.
Thanks, Mike. So as customers are moving into cloud, so some of the patterns which we do see is actually more and more customers are using containers. They are using serverless applications. And the pace of that innovation is much more faster. So for the databases, you want to align for the applications which are actually database centric. Your CI/CD capabilities for application and databases, they need to go hand in hand. There are different variety of databases, right? So customers are moving from monolithic to microservices. So database is moving from one to many databases. So your pace of innovation for application and those multiple databases, these different varieties of databases, they have to go hand in hand. So this is one pattern which we do see, and it's a need for our customers, which are actually migrating to cloud, because key thing is that time to market. You want to do both application and databases together. Also, your automation, right? So there are patterns, there are these CI/CD tools available for applications. So databases has to match those, right? So that is something which customers do ask for CI/CD capabilities of the databases. You want to do your databases changes and applications. Like if you're doing a DDL, you want to make sure that your application change is actually part of that change. Thank you. Next one, please.
All right, so thanks, Harpreet. So database changes need to be treated just like your application code. So we want to make sure we're moving at the same speed with regards to your databases as we are with our application. So today you're automating with your application in terms of source code control. You have validation scripts in terms of the application. You have build artifacts that you're creating as part of your application side and automatically deploying. We also need to be doing that with the database. So what that includes is making sure you're actually versioning your database changes in source code control systems. You're making sure that you're validating those changes now that you're actually putting those for teams to see. We want to make sure that we're documenting those coding standards and people understand what's actually being applied, what standards do they need to adhere to. We want to make sure that we're reviewing those, shifting left, so not waiting until we're at the production system before we review those code, review our SQL scripts. We want to make sure that we're subjecting those same things just like you do for your application, and then delivering at the same speed as your application code and making it automated and repeatable. So along with that, we also want to go faster. So if you've ever heard me talk before, you've heard me say, if you're running into a wall today, going faster is just going to hurt more. You're going to run into that wall, bigger explosions, bigger things are going to happen. So going faster just for the sake of going faster is not always good. We want to make sure that we're ensuring that we have that code quality and compliance. We want to make sure that we're adhering to those standards. We want to be able to more atomically make our changes so that we can easily troubleshoot and keep us on those guardrails, making sure that we're going faster, but also as you go around those curves, you're making sure you're going and stay on the road. And then making sure that those higher, as you go faster, making sure that the quality is still there in terms of making those updates. So in terms of kind of designing and making sure that your system is secure in mind, I'll pass it over to Harpreet.
Thanks, Mike. So as part of these deployment processes, because that shift left, you did talk about that, right? So you want to give that more control to developers, that DevOps or your deployment, you want to actually make them more faster, right? So that pace of innovation should not slow down as you actually move. But that should not be at the expense of security, right? Compliance, that segregation of duties. So if a product does have that capability, that without compromising your some of these security controls, because that is one of the key requirements. In one of my previous organizations, we were actually supposed to provide those audit capabilities, or sometimes auditors would actually ask for the logs. And end of the year, we will have this SOX compliance audits, and we would ask for a specific change that, hey, show me that log for this change, which was actually deployed successfully. Or if there's an error, they would want to see those. So customers don't want to compromise these controls, segregation of duties, as they actually move into a cloud with this tooling. So I have actually one question on that, Mike. So where do customers want to run? Because you are more close on this, working with customers. Where do they actually run these updates, or how do they actually deploy these changes with Liquibase?
So thanks for that. So yes, we do have those questions quite often as you move to cloud, where do you actually run your updates? Some teams have a shared services team where they're running their infrastructure in a shared services environment, and it has access to all the systems. Some teams actually, as they're moving to cloud, may already have application components that talk to the database. So whether you run Liquibase on those application components that already have the security opening to talk to the database, or whether you do it from a shared services model, that's up to you in terms of how you might design this. Because if you run it on the application side, they already have the connectivity. There's not a need to open an additional firewall port or additional security request in order to be able to do that. Other teams are looking at it from a shared services model. It's a Jenkins agent, it's a code pipeline agent that is running, or a code deploy agent that's actually running in that shared service. Maybe it's already in that VPN, virtual private network system. So consider, do you need that from a shared services? Do we already have existing architectures and agents that are able to actually run that? And then in terms of separation of duty, in terms of those pipelines, you have different teams, different service agents that are running those updates in your production systems, and a separate service agent that's running them in non-prod environments.
Okay, and how do we, because this was one of the common theme, that how do we make sure that change is not disruptive? You're not actually dropping something as part of your deployment, and that testing, because in older, I think the old world, that we would actually do these deployments, we would actually get those scripts deployed, so we would actually see the scripts are not doing any harm. So how does Liquibase or this product actually make sure that those things don't get deployed to production with these destructive or kind of changes which can disrupt your services?
Yep. So we have some items, some rules, as well as some quality kind of controls that we can put in place to make sure you're not doing things like drops or truncates or some of these out of the box destructive type things, and make sure we're shifting left, and we're doing that as part of the pull request or merge request process. And so that, as part of shifting that left instead of waiting until the end, waiting until your production deployment. We're shifting left because we're checking things into source control, because we're actually doing merge requests or PRs, pull requests, to validate, okay, are these things actually going to run? We can actually take a look at that code. And if there are errors, then we can actually, is this part of our normal process, or is this something out of the ordinary, to be able to address that at that time, especially with automation that you're not necessarily looking at each and every script. Now we're able to automate some of that process.
Okay, so the review process is actually built as part of this pipeline. So DBAs, or I think some of the security controls, they are actually built in the part of the process. So is that part of the merge request, or where does that fit into this whole, I think, the workflow?
Yep. So as part of that, you can have your DBAs actually reviewing those pull requests so that they're able to more easily and shifting left see those changes as they're occurring or as they're being approved. You can also have those as part of moving into your QA environments, or into as you kind of merge those pipelines into the different environments as you go through your release process. So allowing those teams to be able to see them much earlier in the process. DBAs,
okay,
data architects, etc.
Thank you, Mike.
All right, I'll pass it over to Pete to talk a little bit about the visibility aspects.
This one is my favorite, probably my favorite of the 5, because this is a problem you're going to create for yourself by succeeding on steps 1 through 4. You've now got changes flowing through automation, breakneck speed, keeping pace with the the velocity of your developers, because the database changes are now married to that application build and deploy process. But what doesn't change is our need to be able to understand at a deep level what's going on with each database change. If you've heard me talk before, we all know databases are much less forgiving than application code. You can't just replace a new binary that's not behaving well with an old binary that works. Everything you do to a database is written in stone, because a database has state. So we need to understand at a very deep level what's going on in automation with all of these different jobs. So part of that is making sure that you also build into that automation the capture of that data and the publishing of that data, so that people can get to it. You'll see in the demo in a little bit. What's necessary is to alert your DBAs, alert your security folks if they get involved with any sort of database change, and to alert the developers and the QA engineers and everybody that works on this application. Hey, the database in this shared environment has had changes applied to it. These are what the changes were. This is the job that they were a part of. Just really kind of up-leveling what's happening in automation, so that we don't lose that control that we have when we're deploying these things manually. As Harpreet said a minute ago, we used to know things were good because we would execute them in these environments and we would see the outcome. We need to preserve that experience with database updates for the folks who really are tasked with making sure that the data platform stays available, secure, and performant, all of those things. So baking those visibility aspects into your plan for database CI/CD at the very beginning is going to avoid a whole host of problems that you're going to have if you're successful on steps 1 through 4, for sure.
All right, I'm going to go ahead and stop my share and pass it over to Pete to walk through.
Thanks, Mike. Yeah, so I'm going to show you a demo now, and I like to call it the whole application CI/CD pipeline, and we built it out in AWS, but it's really going to touch on all 5 points that we've discussed to this point. First of all, your process needing to be scalable. I'll show you a capability in Liquibase that allows you to define job templates that are highly portable, reusable, to ensure that there is a consistent sort of build and validation process for your database changes in your CI/CD pipeline across your teams, across your databases, across your applications, everywhere. Treating our databases like application code, the demo will also show you how you can store those database changes in the same source code repo with your application code, making that build a lot easier and contained. We'll also talk about the value of creating branches and having pull requests in a code review process to pull new changes into the mainstream so that we're getting eyeballs on these changes as early as possible to make sure that they are acceptable and they can be promoted further upstream. From the testing and compliance angle, just bringing your database into CI gives you a whole host of solutions that your developers may already be using, from static source code analysis, unit testing, integration testing, functional testing, can now sort of expand. You can broaden your horizons and access the database in those activities. But we also provide a capability that allows you to check for patterns in the change logs or the SQL that you're promoting to your databases. So before they even get executed, you can say, oh, wait, that's something we don't want to do. And the example that Mike used earlier was drops. Drops are truncated. So a lot of times that's the first check that people implement is, hey, I need to be alerted every time somebody's dropping something or truncating a table, because we don't want to lose data. But the Liquibase quality checks should kind of give you that inroad to building testing and compliance into your process. In terms of security, really using a platform like AWS or using any of the CI/CD platforms or combinations, a mix and match of tools, there are a lot of options for how you can keep that pipeline secure, and you can make sure that people get the data they need and don't get the data they don't need access to. And that'll be demonstrated in our demo as well through the use of the AWS Secrets Manager, IAM users and roles, and resource policies, really everything that AWS enables for you from a security platform perspective as you're building out your platform with their services, and then creating that right level of visibility. So what we do in that piece of the demo is, we detect when that database update happens. We save that log to a special place, and then we send notifications out to everybody. So we're really raising the level of the visibility here. For a better view into the services that I used in AWS, and again, we've implemented this in AWS, but we have customers that implement very similar pipelines using AWS database resources, but GitHub or Circle CI or Travis. So, it really kind of applies to all of them. We've used AWS here because of the fantastic level of integration and availability of these services. But we'll start with our developers. They're going to check code into source code control, into code commit, the AWS source code control solution. That commit is going to trigger an event through Amazon Event Bridge that's going to kick off our code pipeline. Our code pipeline is going to get our sensitive configuration information, so our database URL, our database username, our database password, from AWS Secrets Manager. And this kind of demonstrates that separation of duties. Your developers don't need to know the connection information for the environments outside of their development environment. That is best held by DBA or DevOps or your security team, or whoever it is. And Secrets Manager is kind of the bridge that gets that sensitive information into these workflows that are triggered by developers. So that Secrets Manager information will be passed off to code pipeline along with the event that there's a code change. That will kick off our process. The code deploy piece of it will update our web app. The code build piece of it will update our database. And while that's running, again, we'll use Amazon CloudWatch to look for patterns in those log files to determine that a database update was applied. And when we find that, we're going to send that off to AWS Lambda function that's going to take that log and put it in a special place. So we're, in automation, we're building out all of those events that have affected our database in automation. So we've got our audit capability and our visibility, our observability there. And then it's going to use the Amazon Simple Notification Service to email stakeholders. In this case, that stakeholder is me. So to set the stage further, this is our sample app, and this is something that I grabbed out of the AWS Solutions catalog. They have a bunch of great things to get you started with a lot of this. It's a directory, very simple, name and address. I've put some data in here now. And what I'm going to do is I've submitted a pull request that's going to, that contains redesign of that page and also adds a field to it. And we'll get into the specifics of that in a bit. But first of all, this is my source code control repo. So all of my application code and my database code lives right here, and it lives in this source folder. So I've got a folder for my changelog, which I'm using a Liquibase formatted SQL changelog. And it's really just, a few specialized comments, but it really is just SQL statements that get executed to migrate my database throughout the various versions. Because this is such a simple application, I really just have one change set, and it's creating that employees table. This is sort of the core, the main branch of my repo here. But it just sits right there in a directory next to my HTML code. So this is where I've got my PHP file, and in my merge request, I'll be adding stuff as well. But this is the pattern you want to establish. You want to start from source code control, having these things tied together very tightly. So we'll take a look at my pull request next. And what my pull request does is it tells you it's going to redesign the directory page. It adds that phone number. But what we can do is look at the commits or the changes rather. And this is where the code review comes in. Prior to merging this into main and making it available to the rest of my pipeline, we can assign people that have to review these kind of changes before they can move further in the process. So this is kind of step one of building in that quality, that review, that certainty that everything is going to remain compliant as it goes through the pipeline. So as we can see here, we've got our Liquibase changelog, and I'm adding that column to the employees table that's going to allow us to put in a phone number, and I'm going to give it a default value. So everything that was there before will at least have a value there. But that's the extent of my change. So your database SME, whether that is a DBA or a developer on your team who owns that responsibility of making sure that the data practices are safe, they're going to put eyeballs on this before it even gets outside of your development environment. This looks like a good change to me. A bunch of other changes. These are all of the changes to my index.php, and I added a style sheet. So there's quite a bit going on in this change. So I'm going to go ahead and merge that. Looks like I can do so cleanly. And that's going to kick off an automated process in code pipeline. So this is my code pipeline job, and there's really two distinct states here. That merge should have kicked off. Yep. So this just kicked off. It detected that merge of the pull request automatically into my main branch. And this always operates off main. So that merge of the pull request is going to be the trigger to run the CI process for this project. This first step is really just getting all my source code control bundled up and ready to go. It's then passing that off to my build step. And in my build step, there's two sub-steps. First, I'm going to deal with the database. I'm going to run Liquibase quality checks to make sure that the changelog is adhering to all of our best practices, is in compliance with all of our best practices. And then I'm going to update the database. I'll inspect the state of the database afterwards to make sure that the end state of the database is what we expect it to be. And then I will, and then we'll move on to the next step, which deploys the application files. So to show you how simple this build piece is, I would like to share with you the build spec. So this is what tells code build what to do. Pretty simple. It's got phases. Install is just kind of installing the runtime we need to affect the changes. We are echoing the build number, so we have that in the log to refer back to. And then we're really just running one Liquibase command. And it's that concept of Liquibase flows, these portable templates that allow you to, repeatably scale out across multiple teams, across multiple projects, the same CI/CD workflow. So it's referring to this flow file, which also lives in my repository. So I'll go back to my repository and show you what's in that flow file. So what you'll see, there's a bunch of Liquibase commands that we're actually running right now in different stages. So we're validating our changelog first. This is where we run checks. It's where we run a validate command to make sure that our changelog is well formed. So before we even get started, if we detect anything in either one of those commands, we're going to stop the process, throw an error, and let everybody know that there's a problem. Once that passes, we'll go on and prepare the environment for the update. So the first thing we'll do is we'll tag it where we are now, so we can always get back to this point after this build or sometime further down the road. And we're going to run status just to see what kind of changes have already been applied to our database. And all of this is coming out to the log. I'll show you in a second. Then it's time to update. So the first thing we'll do is we'll run the Liquibase update SQL command that will print out all of the SQL that's going to be executed. We'll do the actual update of the database, and then we're going to run checks on the end state of that database. So you can run checks on the changelog to capture things before they happen, and you can run things just kind of arbitrarily on a database at any point in time. What we're doing here is kind of checking that post-deploy state to make sure that what we're looking to accomplish has been accomplished and we aren't violating any rules with the end state of that database. And then finally, we'll run history, which is just going to print out every deployment we've done on that database in our log so we can keep track of sort of the running history of that project. The great thing about this is you'll notice there isn't anything specific to this application, to this repo, to this database at all in this file. So really all you need to do is take this, plug it into another Liquibase project and run it. And it'll do all of the same steps. You could be using a different database. You could be using a different kind of changelog. Whatever you're doing, you're going to be able to use this file over and over and over again. And that makes it a lot easier to get a consistent, standardized process across all of your teams. So we'll go back to our code pipeline, and it looks like our job succeeded. So what we're looking for here is, here's this log file, and this is the output from the flow that I just showed you. So you can see we've got our changes referenced here, validate changelog, no output there, so we were all good. We're running our checks. So this just kind of gives you, I didn't have any of our checks actually break the build just in the interest of time, but you can configure these checks to be errors or informational or warnings, whatever you want to do, whatever makes sense for you. But we have several checks that we ran against the changelog, and it didn't find several things, but none of these things were enough for me to want to stop the presses. But we do now have all of this information captured in this log. We can see what checks were run, what the outcomes were, and it's preserved forever in this log, as I'll show you in a second. Then we go through our update steps, our preparation and update steps, so you can see that we're applying a change set. Here's the SQL that we're going to run as part of this update. So now we have a record of this that's going to get persisted to the store where we keep all of our database update information. We ran the update. It completed successfully. We ran those checks against the database. The database is clean after the update. So everything passed. We're good here. We're now in the end stage where we just list out the history. So this is great. We updated the database. It preserved all of this great information in this log file. So what's the process for getting that log file persisted to the S3 database? Well, that's what happened in our Lambda function. I won't go into the Lambda function because it's a bunch of code and a bunch of logging, but essentially our Lambda function takes this log, moves it to our S3 bucket, and sends us our notification email. So our job went okay. Here's our the S3 bucket where we're keeping these updates. If I refresh this, I should have a 9/29/2022. And I've got my log file here. So this is the log file for the deploy that I just ran. But, because I'm a very busy person and I don't have time to hit refresh on my S3 bucket all day, I also received an email notification that lets me know that change sets were executed by Liquibase on my database. I can click here. It will automatically download the log events for that file, which look like this. I don't quite have this printing out like a flat log file right now. It's a log event for each message in the file, but you get the idea. Everything that just happened is now being delivered to my inbox. When it happens, I don't have to follow up and say, hey, was this database updated? What happened in that time? This, that, and the other. I've got all of that information at my fingertips, and it's going out automatically to all of my stakeholders. And when I go back to my application and I refresh it, my changes have been applied. I've got the list of people with their phone numbers. It used all the defaults because none of them had phone numbers before. My styles have been applied. And I've now, in a single job, moved those application changes and database changes through the pipeline, exhibiting all of that, all of the best practices that we discussed earlier, all the considerations that we discussed earlier. So it really does provide a way for these changes to move much more quickly with less human intervention without sacrificing the visibility, the safety, the assurance that what you're putting out into production, even though it's going through largely hands untouched, is not going to cause problems when it does hit that production environment. And then you've got the traceability for audits and things in that S3 bucket, because we're moving every little bit of information we can about those database updates into that S3 bucket. The next step on this for me is to start using Athena with that S3 bucket, so I can start querying those logs and making discoveries about how I'm operating, and maybe even pushing some of those discoveries and metrics into QuickSight, Amazon QuickSight, so I can keep track of what's going on across all my pipelines in my organization. But I think this really does kind of encapsulate what we're talking about here, that hands-off, but still high quality, highly secure, automated workflow that's going to allow your database to zoom just as quickly as the application can. So back to our slides. So while we don't have that whole demo environment built out, we do have a quick start that Mike and someone else here put together in partnership with AWS. Mike, do you want to tell us a little bit about the quick start?
Sure. So thanks for that, Pete. Thanks for the amazing demo and kind of walking us actually through that. So Pete actually took our quick start and enhanced it. So it's meant as a template to kind of get you started in understanding some of the things that Pete talked about. So we started out with being able to very quickly and easily just take one of AWS's quick start and ask you a couple of questions and then spin up something very similar to what kind of Pete showed. So in terms of the users, we're going to spin up a code commit environment. We're going to use CloudWatch in order to be able to, that's that webhook that's monitoring for updates for your database. And we're going to store your database secrets as well as the URL for your database connections, just like Pete showed with the secrets manager. Once you actually check in your code for your database update, we'll actually kick off a code pipeline through CodeWatch, is basically monitoring their source code system. And it kicks off a build as part of that process and tells Liquibase, hey, I need to actually go update the databases and take that code. There's also an approval process that we've kind of put in there to kind of walk through, okay, do I want to actually go and review that code and continue forward to the next environment? As part of our build environment, as part of our logging and auditing capability, we're putting those items into an S3 bucket and then deploying the database changes through Liquibase Pro to update your test database, your staging database to your production database. So being able to push that all the way through your database pipeline and kind of show you what's possible in terms of using AWS resources. So very simple, very easy to kind of get started in terms of whether you want to deploy that into your own VPC, virtual private cloud, or whether you want to establish a brand new one just to kind of get started. And there will be slides. These slides will be linked in as part of once we actually send out the information for this webinar. Sorry.
Great. Thanks, you guys. That was a great demo. We've got a few questions that we can cover here. And in the meantime, if there's more questions that the audience here has, feel free to put them into the Q&A panel, and we'll see which questions we can get to. We should be able to get to most of them here because we still have a little bit of time, so should be okay. So to start, Mike, Sukan asks about database treating database changes as application code. The statement here of application code needs business logic and the database does not need that type of change. Does the database design need to change? Maybe you can go a little bit deeper into what we mean by treating the database changes like application code.
Yep. So today you may be just putting the database code into a ticket and having a DBA actually run that. So treating it like application code, well, application code is stored in source control. So that's one of the first steps, is storing your database code in your application code. Now that you have it in your source code system, now we want automation systems to actually pull that out of source code and actually run it on your database through your pipelines, your dev, your test, your QA, pre-prod, your prod environments, right? And so we're using Liquibase along with your automation tools, your CI/CD tools, whether that's the Jenkins or whether that's a code pipeline, right? To actually deploy those changes in terms of automating that, using quality checks and making sure that that's actually working and running, and you have that compliance as part of that PR process. Again, you have a PR process, a pull request process to validate, okay, is this code that we actually want to merge it in? So again, back to, treating it just like your application code. Some teams will actually look at stored logic as application code that's just in the database. So depending on whether your application code is totally outside and all in your application, or maybe you're starting to put, in terms of performance, you've had your application logic, some of the application logic for looking up at that information as part of stored logic, stored procedures, functions, etc. That's application code to some folks in terms of being able to manage that. And so making sure that people are reviewing that, making sure that that's compliant, making sure that that actually does what you think it's going to do as part of that. And so that all comes into treating your application or your database code just like application code. Hopefully that answers the question.
That's great, Mike. And I would just add, one of the big challenges that we see from a lot of our customers is the application code goes smoothly into the different environments, and it's the database changes that really get hung up. And so we're really talking about pushing those changes together through the same pipeline, so that they're delivered together and with the same speed and quality as pushed to the environment at the same time, as opposed to having to run different processes. Great. That kind of pulls into a question from Milind here, which is are application PRs assigned to application developers and changelog PRs assigned to DBAs for code review? Or do you see that as is there a different model that we recommend there?
I mean, I think it really depends on your organization. If you do have a requirement that DBAs need to review all database changes before they enter the pipeline, then you would want to set up your process so that when there is a database change, you have a specific person review it. And most of the, like Code Commit, I know has rules that you can apply to pull requests that says, this person needs to review it, that person needs to review it, or, this group of people need to review it. So you can set up rules like that, and pretty much any platform or Git-based platform that I've worked with that uses pull requests. So yeah, again, it's your organization. If you have one person that can and does do both, then they're the only one that needs to review it. But if you do have that DBA requirement, you can make sure that DBAs get pulled into that by establishing rules around how pull requests are merged.
Great. Let's see here. We've got another one from Igor who asks, what would you suggest for applying different changes in different environments? For example, would we to insert prod into ABC table in the prod environment, test into the ABC table in the test environment?
So I can take that one, and then the rest of the team can kind of add as well. So there are different ways that you could potentially do that. So if you have, as your example, there's table A, ideally you want the same name across to make it easy. So it's table A in dev, and it's table A in QA, and it's table A in prod, and that makes it much simpler. If you do have the requirement to have different names in there, we do have the capability of doing property substitution. So in dev, it's called table dev. In QA, it's called table QA. And in prod, it's just called table. As an example, we have the ability to kind of put that into play. And then in terms of kind of the, from the environment perspective, you're connecting through a URL or abstracting that out. And so it's outside of the code itself in order to be able to make sure that your pipelines are secure and connecting to the right systems. And so you're connecting, abstracting that out in terms of the database as code updates. Others have additional comments?
Yeah, I think, Mike, that's right. Schema, typically you would want to have the same schema. I don't see any reason because most times, at least in my personal experience, we used to refresh our non-prod from production. But your data scripts can change, but that will be at the runtime that you do your deployment. And that may be a question for Pete. So Pete, you mentioned that this is actually from the master branch. Can we actually have this from the different branches, like developer do run this from their dev branches, production actually goes into from your production branch?
Yeah, absolutely. You can follow that pattern. In fact, we do for internal development, even with our database applications. So you've got you push your branch up, and that kicks off. It could kick off a very similar, if not the exact same code pipeline build. And then you use the results from that build as one of the criteria for whether or not it's ready to merge into master or main. It's flexible. Like we said, we really want to make this as much like managing application code as possible. And the way we've structured the product and the way we've sort of designed these practices, it follows a lot of the same thing the application code does. So branch builds are very much on the table. It just in this demo, I had it going off of main, and main is what does the automatic trigger for that.
Okay, thank you. Yeah, so this could be at the branch level. This could be at the, because schema typically you would keep same. Mike, I hope you answered that.
There's one question here now that this one should be an easy one, I think. So whoever, probably maybe Mike or Pete, this can be best for you, is of all of the Liquibase pieces demoed, this is the question from Tim, are there pieces that are only in the Pro edition besides quality checks, or is everything else in the open source version?
So the flow, the Liquibase flow technology, those templates that outline workflows, is also going to be a pro capability. But yeah, everything else other than the QCs and the flows, everything else is in the community product. And the community product, I mean, you can do a lot of the same stuff. You just don't have kind of the convenience of that flow file for repeatability. But you can, you just wire up your jobs to use those individual commands instead of the plan that describes what those individual commands are.
Part of the reason we did that is to be able to easily abstract out and be able to enhance your updates as you need to. So if you want to do additional configuration, you want to do additional updates, you want to standardize, back to Pete's original comment in the demonstration, being able to standardize across repositories, across systems, across the organization, and have it very easy. Okay, here is the system that we're going to use. Here is the pattern that we're going to use for all of our Liquibase changes.
So I've got one question here that I think is very interesting from Aruk. Is the Liquibase CI/CD pipeline bundled as an AWS service? I'm going to answer that. The answer here is no. We do offer it through the AWS marketplace. It's not a particular service on the AWS platform by itself, but you can always talk to your AWS friends and see if that's something that they'd want to figure out. But it's independent of AWS at this point, which I would expect to kind of remain that way. So there's a couple questions about GitLab and whether we have a demo for GitLab with Liquibase and an AWS RDS database, and whether Liquibase is compatible with GitLab as the code commit source. Mike, correct me if I'm wrong. I think we do have something written up around GitLab and Liquibase that we could share out. I'm not sure whether it specifically goes along with the AWS RDS database, but we can probably look into that. So we can get that out to Sangizo, who asked the question. But as the code commit source, can you comment on Liquibase being compatible with GitLab as the commit source for the code?
Yep. So we can definitely do GitLab. There is a template that you can actually use and utilize for source control. Whether again, as you run through Liquibase, will utilize different CI/CD tools. You can use GitLab. You can use AWS code pipeline. You can use other CI tools. So yes, we have that compatibility. We also have a toolbox, a public toolbox where you can kind of take a template and massage that and update that based on your technologies, right? There's different types of databases that you're connecting to. There's different source code control systems. There's different CI/CD tools. And we're meant to work with all of those and kind of drop in back to making it much easier. We continue to try and make it easier and easier and easier as you kind of migrate through the different technologies.
Okay, and we're probably not going to get through all of these questions. There's a lot here now. I think people are really come in hard on us here. Let me just pick out a couple that I think people would really that maybe the most folks would get the most out of. Here's one we always seem to get in each of our webinars is how are potential rollbacks managed in Liquibase? Are you able to generate rollback scripts for databases automatically? Pete, you want to hit that one?
Sure. So there are a lot of ways you can manage rollbacks with Liquibase. For some changes where we can confidently infer what the undo step would be, we can generate those rollbacks. We don't do it for everything. So if there was a drop table, we don't capture the previous state of the table so we know what to roll back to or capture that data or anything like that. So for anything that you want to do that undoes a destructive change, we don't do that automatically. You kind of have to write your own script to do that. But really, our best practice, our recommendation is to take a stance of roll forward, just because rollbacks can be so tricky. Just for the example I just gave, if you don't do it just right, you can end up losing data that's been collected between the time that this went out to production and the time you realize, oh, we've got to roll this back to a previous version for whatever reason. So if you are going to use rollbacks instead of roll forward, we recommend that you author them yourself so you know exactly what's going to happen during that rollback phase. But other options to look at are progressive and blue-green deployments. So, update the database to a certain state that can manage both versions of the service or application you're about to put out. And maybe there's an additional trigger there that's copying information, data from one table to another to manage those two states. And once you determine that piece of your infrastructure is performing optimally, you don't have a spike in issues, you don't have a drop in performance, you roll that out to the rest of your organization. And then, you can clear out the things that you hadn't put in place to support both of those applications. That's if you want to do kind of a zero downtime, test of that version in production before you roll forward. And then another way, the way that we do really recommend though, is if you do run into an issue, you do have something you need to fix and it is just in the database, instead of rolling everything back, just introduce a new change that addresses that issue and push it out as a hot fix. So it'll go in, it'll update the database the way it needs to, it'll address the issue that you're seeing and move forward like that. But yeah, that's really to sum all of that up. Maybe a blue-green deployment or a progressive deployment approach would work for you if you're having to roll back frequently. If you do want to use the rollback capability, we highly recommend that you create those rollbacks yourself so you know exactly what's happening as part of that. But when you can, roll forward, just, take the state of today, increment it by one to address that issue, and then move on.
And then I think I'm going to just hit two more here real quick, and then I think we're coming down on time. But there's some things here that are questions about the quick start that was provided. The AWS Liquibase quick start is provided and supports Postgres as the database. Is there anything similar for AWS RDS or Aurora MySQL, or do we just use the same quick start and use it for Aurora MySQL?
So we had to start somewhere. And so we just started with a database. Can you take that quick start and massage and do it yourself? Yes, we have the source code there to be able to configure it if you want to, if you understand how quick starts work, or if you understand how CloudFormation works. Yes, you can take that CloudFormation template make it work with an RDS, a MySQL, another database technology, and just use that as a formation for your own other databases. So just, again, we were just trying to make it simple to at least kind of see what the technology can do, set things up for you, and then at least give you a template to get started with if you wanted to additionally add that to your own systems.
And what I did, Mike mentioned that I use that quick start as the seed of the broader demo that I just did. And the sample application I used was written for MySQL. So I stood up the quick start. I created a new MySQL database and just kind of plugged it in, and it worked fine. So that's an option for you as well. If you want to just go with it as is and then kind of manually create the resource you need, you can use the other resources that were created as kind of your guide to get the VPC configuration, the policies in the right shape, and then you can be off into the races. It wasn't, if you've spent a little bit of time in AWS, it was pretty straightforward to do that.
All right, and then the last one that I think we should cover here is there's a few questions on CI/CD services for on-premise databases. Maybe we could just touch briefly on how Liquibase supports on-premise databases, and is it different from what we just talked about for AWS?
No, not really, because Liquibase gets integrated into your CI/CD tool chain, and that's very much by design. We've tried to create a flexible solution that you could apply almost anywhere. So really, everything that you saw that Liquibase did in our CI/CD platform was driven through kind of headless command line interactions, and you can do that in any of your tools. In fact, we've got several customer and community examples of people managing huge on-premise infrastructure using Liquibase in a very similar manner. So everything you saw today in terms of managing that process, that CI/CD process through a pipeline, is just as applicable to on-prem as it is to cloud use cases. What's different are sort of the surrounding services. So whatever the log aggregator or log analytics platform you use is, that's not CloudWatch, or whatever you're using for the visibility pieces, all the sort of little surrounding services. That's where it differs a little bit, but those things aren't really integrating directly with Liquibase. What Liquibase needs to do, it can do in any kind of pipeline pretty easily.
Great. So I think there's a lot more questions here. I think we're going to have to take a few of them and do them offline. I really appreciate everybody's attendance. We've amazingly kept a ton of people around. We haven't had a lot of drop off here. Usually you get a lot of drop off when you hit the question area. So this has been a very, very exciting question and answer session. We will go back through the questions and see if we can't come up with the answers for some of them, and at least reach out to those that ask questions on them, and see if we can't get those answered. The other thing is that I would recommend, there were lots of questions around very specific, using Liquibase in very specific scenarios. I would urge you to reach out if you are considering Liquibase for as a commercial, considering our commercial offering. I would urge you to reach out to our sales team, and Mike is likely going to be the one that helps you. It's him or somebody who works directly with him that will be able to show you exactly how this is going to work in your own environment. And then we also have a very vibrant community that you can go out at forum.liquibase.com and liquibase.org. Actually, I may have gotten that wrong. Hold on a second. I think it's forum.liquibase.org. So our liquibase.org site is geared towards our community. We've got there's lots more here listed on this slide to talk about how to get a free trial of our pro offering, to get a custom demo. You can go and get started with Liquibase University, as well as our documentation. And then, of course, the AWS Quick Start is here. We will send out the slides. We will send out the recording as soon as we can pull it down and get it ready. Appreciate the activity, and appreciate our panelists today. This has been an amazing webinar. I hope you enjoyed it. Thanks all.
Thanks, everybody.
Thank you.
Thank you.